Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of using the Pythagorean Theorem. This is standard 8.7c in the great state of Texas, and we are using item number 38 off the 2021 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a diagram here of a pretty long, 60-foot long representation of a right triangle that's supposed to be a ramp, but really we just need to find the length of the ramp in feet. So here's my ramp, and so I'm looking at the length of this diagonal right here. And so when we're looking at this right triangle, we need to go ahead and label some of these. And so right triangles always have 3 sides, obviously, because they're triangles. But the 2 sides that connect to form this right angle are both called legs, right? And so we're actually going to put letters on these. And so we call these A and B. It doesn't matter which one is A, which one is B. But the side that is directly across from the right angle, the diagonal, has a different letter. It's called C. So we just label the 2 legs A and B, and the side across the diagonal is always C, but it has a special name as well. It's called a hypotenuse. And so 2 legs and a hypotenuse always make a right triangle. The hypotenuse is always C. Now, why do we care about these letters A, B, and C? Well, when we're thinking of a right triangle, we should be thinking of the Pythagorean Theorem, which says a squared plus b squared equals c squared. What does that mean? Well, that's why we label the 2 legs A and B. If you were to make some squares, and this square would actually go off the screen here, so just pretend this is a full square, and the side lengths are A, right? So I've got an A there and I've got an A there. If I want to find the area, this is going to be my A squared. If I want to use B here as the side length of another square, so there's another B, my area is going to be B squared. And what we find is that if you take these 2 areas right here, A squared and B squared, you add them up, guess what you get? You will always get, pretend this has got a square on the side length here, way off the screen, you always get the area of c squared. So a squared plus b squared always equals an imaginary square that comes off the side of that hypotenuse, no matter the size or dimensions of our right triangle. So we can use that to find these missing side lengths. So a squared plus b squared equals c squared. Well, that helps me out because my a is 60, so I'm going to say 60 squared plus my b is 11. So I'm going to say 11 squared equals c squared. Now I need to do a little bit of squaring. So 60 is squared is not 60 times 2, it's 60 times 60. So 6 times 6 is 36, and then I've got 2 zeros. 3,600 plus 121, most of us have that. So that's going to equal c squared. So I've got 3,721 equals c squared. Now we're not done. That is a exponent there. And so what we need to do is we need to get rid of that exponent. And the way that you can use an inverse operation to get rid of exponents is to use roots. So since it is c squared, I'm going to take the square root. And that's how you isolate that variable. But you got to do it to both sides. So let's take the square root of 3,721. Definitely use our calculators here. Need a nice even integer, 61. So we just need to make sure we bubble this in correctly. And we won't draw the whole thing here, but we got a decimal point. 2 digits to the right of the decimal, you don't need either of them. There's no need to put a 0. You're just going to put 61. Make sure you bubble in the correct digits underneath. Like I said, you don't need any zeros to the left or to the right. You also have a plus and a minus here for a positive and negative. You can just leave that alone. If you don't bubble in the positive, it is naturally assumed to be positive.